Okay, so in this problem we are going to be given a volume and we are going to be asked how many molecules are in that volume. So let's give this question a read. A male adult takes about 5 times 10 to the negative 4 meters cubed of fresh air in one breath. Normal air contains 21% oxygen. Assuming that the pressure in the lungs is 1 times 10 to the 5 pascals and that the air is an ideal gas at a temperature of 310 Kelvin, find the number of oxygen molecules in a normal breath. Okay, to start this off, I am going to write out the equation that we'll be using, which is PV is equal to nRT. Alright, so the P is the pressure, the V is the volume, N is the number of moles, R is the gas constant, and T is the temperature. So what we're going to be solving for here at the start of the problem is the number of the moles. So when you get N on one side, it will look like PV over RT. And so we'll solve out for that because we have these numbers here. So for the pressure, it is going to be 1 times 10 to the 5th, multiply that by the volume that we are given, which is 5 times 10 to the negative 4, and divide that by the gas constant, R, which is 8.31, and then we are going to times it by the temperature that we are given, which is 310 Kelvin. So when you work that out, you should get a number that will look like 0.019409 mole. So this is, we don't even have a full mole here. So using this bit of information, and when you solve out for this, don't do any rounding and just keep that number in your calculator because we will be using it in a second. So there's another equation that we'll be using, and it is the number of moles, little n, is equal to big N, the number of particles, divided by Avogadro's number, which is NA. So we have little n, the number of moles, and we also have Avogadro's number. So we're just solving for this big N here. So let's rewrite this out as big N is equal to the number of moles times Avogadro's number. And that will look like this value that you still have in your calculator, 0.019409, times Avogadro's number, which is 6.022 times 10 to the 23rd molecules per mole. And then after you do that, you will get the number of particles for the system will equal out to be 1.1688 times 10 to the 22nd. So this is the number of particles that are in the lung. But if you read the question, it says the air contains approximately 21% oxygen. So what we're going to want to do to figure out the amount of particles of oxygen that we have, we are going to multiply that by 0.21. And what we will get is 2.45 times 10 to the 21 oxygen. Particles. Okay, hopefully that helped.